5-1A, alternative lesson example number 2. The point 0, -4 is on the graph f of x equals -2x squared minus 4x minus 4. Use symmetry to find the coordinates of another point on the parabola. So if we're to look at the parabola, y equals -2x squared minus 4x minus 4, and look at the line of symmetry, remember our vertex right here. Let's go ahead and make sure we identify that. So this is our vertex. It's where the curve points. So our vertex has coordinates of -1, -2. So our line of symmetry is our line of symmetry is x equals -1. So that's our line of symmetry right there. Okay? So this causes a reflection. This is a point where the parabola is reflected upon. Point. I keep saying point. It's the line. So if we were to fold this parabola over that line, it would fold on top of each other. All right? So they told us that 0, -4, which is this point right here, (0, -4) is a point on the parabola, which it is. So using symmetry to find another coordinates of another point on the parabola, well, if we look here, if we look straight across, now look straight across to this point, this is exactly the same distance away from the line of symmetry, so we're 1 unit apart, and we're the same vertical distance in terms of in relation to the vertex, so we're 2 units down. All right, so if this is 0, -4, this is, so let's see, this is 1 unit over, 2 units over, so this is going to be -2, -4. So that would be another point on the parabola, and we'll use the line of symmetry in order to be able to find it. In other words, if we were to fold this parabola over itself, this point would land on top of this point right here. Let's find another point of symmetry. Let's say here's a point right here. Okay, this one is 1, -10. This is 1, -10. Now if I look at the distance from this point, the horizontal distance from the line of symmetry to the point, we're 2 units away. 2 units away. So what I'm going to do then is go 2 more units to here. There's 2 units here. We're the same vertical distance from the vertex, so I have another point here on the parabola. Let's see, I went from 1 to -1, so I'm going to go 2 units further to the left, so I'm going -1, so this would be -3. So this point would have a coordinate of -3, -10. Okay? And I could do that for any point on the parabola. I could use the line of symmetry and use the reflective point to locate another point on the parabola. Alright, so we have 2 points. So if I have 0, -4, my reflective point would be -2, -4. If I have a point 1, -10, I have a reflective point -3, -10. Okay? And I could continue on at any other point along this line. Alright? Again, all I do is I take the point, I find the distance. Actually, if you took a straight line from here to here, notice that all these lines lines right here that we've used to find the reflected point form 90-degree angles with the line of symmetry. So it's real easy to locate it. Gee, if we know this distance right here, if we know this distance from here to here, that's going to be the same distance from here to here. Those distances will be the same. And in all cases, these would have the same vertical distance from the vertex.